Hello all. Today we'll discuss Newton ring. Suppose if I have a plain glass plate over which if I place a plano-convex lens and shine a monochromatic light, and if I see through the microscope, what kind of pattern we will get? Will we get completely bright region or completely dark region or concentric bright and dark rings? The answer is concentric bright and dark rings. Let's discuss the reason behind this. Here is the typical experimental arrangement of Newton ring setup. Here we have a monochromatic light source which gives a light, spherically diverging light, and that is being parallelized with the help of a double-sided convex lens, and this parallel beam faces the 45-degree angled glass plate, and there will be a reflection and refraction, and this refracted ray we are concerned mainly, and this reflected ray goes to the plano-convex lens and thin film of air that is being formed between the plain glass plate and plano-convex lens, and this reflected light is being observed through the microscope. Here is the size comparison of the radius of curvature of the plano-convex lens and the thickness of thin film that is being formed between the plain glass plate and plano-convex lens. So the typical experimental value of R will be in the range of 1 to 2 millimeter, whereas the thickness of thin film between the plano-convex lens and plain glass plate will be in the order of 1 to 2 millimeter. So it is roughly 1000 times lesser than the radius of curvature of the plano-convex lens. So in my previous video I have discussed the path length difference between the two rays that are getting reflected from the thin film of uniform thickness T and refractive index mu, that is this one. And in the present case we also have thin film that is made of air, also it is of wedge shaped. So again the same relation can be used. So our aim is to find T, expression for T in terms of R and radius of curvature of the plano-convex lens, where T is the vertical height at which we have R means R radiused bright or dark fringe. Okay, now using Pythagoras theorem we can write R as this R squared can be written as R minus T the whole squared plus R squared. Okay, now expanding this and cancelling R squared gives only this, and as I told T will be much lesser than R, and again if we square it will be much lesser than R, so T squared term here can be cancelled, and this is the resulting expression R squared minus 2R. So on the right hand side 0, R squared is equal to 2RT, where R is the radius of mth or nth bright or dark ring. Okay, now rearranging this expression gives me T is equal to R squared divided by R 2R, and substituting this in the path length difference expression, that gives this. And again for a thin film of air which has refractive index of mu, and for normal incidence angle of refraction will be 0. Substituting this here we get this expression, path length difference is equal to R squared divided by R plus lambda by 2. So applying the condition for bright indifference means constructive indifference, if we apply this we will get bright ring. Okay, so delta for R to be a radius of bright ring, the delta L should be m lambda. So delta L is equal to Rm squared by R plus lambda by 2 is equal to m lambda, and rearranging this expression we get the radius of mth bright ring as this one. Now applying same condition for dark ring gives, so delta L path length should be odd integral multiple of lambda, and simplifying this expression gives the radius of mth dark ring. So the radius of mth dark ring is directly proportional to square root of the order of dark ring m. Okay, now if we know mth and nth dark ring radius, we can estimate, okay, radius, subtracting these two radius, we get m minus n lambda of r. Okay, so I am subtracting the squares of radius of mth and nth dark ring. Okay, both are dark ring only, but they are two different dark rings. If we know lambda, rearranging this expression can give the radius of curvature of unknown plano-convex lens, whose radius of curvature we don't know. That can be estimated if we know lambda and these differences. Okay, now if we know r and if we don't know lambda, we can find the wavelength of unknown light source with the help of plano-convex lens whose radius of curvature we know using this formula. Now there can be a question why the center of Newton ring is dark. So as we know, at the center r is equal to 0, and substituting r is equal to 0 in the path length difference expression, and we get path length as lambda by 2, and this is exactly the condition for dark ring. That is why the center of Newton ring is dark. Okay, that's all. Thank you.